So we'll find the use of multiple factors for one more important concept, which is HCF and LCM in mathematics. What is the HCF and LCM? We will see with the help of an example. Well, if I said, find out the factors of two numbers. First of all, I said that you find the factors of 12. Okay. And it is said that find the factors of 27. Fine. Now, what are the factors of 12? Yes, 12 can be divided by 1, first factor. Then it can be divided by 2, it can be divided by 3, it can be divided by 4, it can be divided by 6, and lastly, it can be divided by 12. Well, how to check that you have find out all the factors is you take first number, first factor and last factor. You multiply them. 1, 12 or 12, 1, 12. Now you take second and second last. 6 twos are or 2 6 are 12. Now you take 3 4s are 3 4s or 4 3s are 12. So if I go like this, so I will get that 3 4s are also giving the same number as 12. So we have found out all the factors of 12. Now what about 27? What are the factors of 27? Well, factors of 27 will be 1. 27 can be divided by, now it cannot be divided by 2. We will go for 3. And we can see that it can be divided by 3. And the answer will be, when 27 is divided by 3, 9 3s are 27 or 3 9s are 27. Let us go for 4. Well, 27 is not in table of 4. It's not in table of 5 also. Not in table of 6, even not in table of 7, 8, it is not there. In table of 9, it's there. So 9 3s are 27. Okay, now what will be the next then? Well, if you try for next numbers after 9, we cannot find any number up to 27 which can divide 27 exactly without leaving any remainder. And what we got is only the 27 can divide 27, and then in that case, the quotient will be 1. So let us check again whether we find all the factors of 27. 1, 27 are 27. 9 3s are 27. Yes, we have find out all the factors of 27. Now no factors of 27 are remaining. Now we will list out the common factors. Why common factor? Because this common factor will be all the factors which are common to both the numbers. They can divide both the numbers exactly without leaving any remainder. For example, 1 is there. 1 can divide both the numbers. Then we are having 3. Thus we are having any other common factor or common divisor for 12 and 27? No. Now what is the highest factors in these common factors which can divide both 12 and 27 exactly without leaving any remainder? What I want, okay, we'll just frame this question in the mathematical statement. Say, if suppose a person is having a red ribbon of 12 meter length and blue ribbon of 27 meter length. Now he want to make the pieces, equal size pieces of the ribbon without any vestige. He don't want to make any vestige. But the red ribbon should be, the piece of red ribbon should be equal to the piece of blue ribbon. We are having a red ribbon of 12 meter and blue ribbon of 27 meter. Now he want to cut the pieces in such a way that both the pieces, red piece and blue piece, should have equal length, and there should not be any remainder. There should not be any vestige of ribbon. How should he go for? Then he want that what he need is the numbers which will divide the 12 and 27 exactly without leaving any remainder, and that number is 3. So if I make 4 pieces of 12 of 3 meter, 4 pieces of this red ribbon 3 pieces I will get. 4 threes are 12. What about the blue ribbon? Blue ribbon, if I made one piece of 3 meter of a blue ribbon, I will get the 9 pieces which are equal in the length to the red ribbon pieces, and will not be having any vestige, will not keep any remainder. So here comes the use of this common factor, which is the highest common factor. Well, I can make the pieces of 1 meter also of blue ribbon and red ribbon. Well, all the having the length of 1 meter, but that will be an easy thing. And what I want to make the ribbon in such a way that the pieces in such a way that they will having maximum possible length. So in that case, when I want the maximum possible length, the maximum possible length of ribbon pieces will be of 3 meters. So we will say that the highest common factor highest common factor is 3. Means I am suggesting that person that you make 4 pieces of 3 meters of 12 and 9 pieces of 3 meters of 27, and there will not be any vestige, and you will get the equal size pieces of blue and red ribbon. So we have get the answer. So see, this is the use of finding the factors in real life, and what we get the highest common factor. In short, we are writing this highest common factor as HCF, highest common factor. This is also known as a greatest common divisor. In short, it is written as GCD. Both HCF and GCD, greatest common divisor. So in both the cases, means HCF or GCD, these are the two names of one person. Both are leading to the same answer, means both are having same meaning. This is the greatest common divisor, which when we divide this, we'll get how many number of pieces to make. So for 12, we have to make 4 pieces, and for 27, we have to make 9 pieces. Then the pieces will be of equal size. Okay. Now this is the use of HCF. Now we will go for what is meant by LCM. It is said that find the multiples of 2 and 3. What are the multiples of 2? Very easy. It is very easy question. 2, then we are having 4, then we are having 6, then we are having 8, then we are having 10, 12, 14. So how many multiples are there for a number? Well, you can write up to infinite. See, what up to yet we have seen is that the factors, we have found out the factors of a number. Even for 120, the number of factors are limited. Even for 120, the number of factors are limited. Even though it's have a large set of factors, what about the multiples of a number? We can write the multiples of a number for an infinite number of times, means infinite. So actually a largest multiple of a number is undefined. We can find up to infinite. So I have done the dash. Now we will find out the multiples of 3. We are having 3, 6, 9, then 12, 15, 18, and so on. Many more. Now we are going to underline which are the multiples which are common to both 2 and 3. You can able to see that there is a 6. Then we are having 12. Then if I go for adding this, calculating this, we are having 16 and 18 also. And we are having 18 common. So if I jot down all the common multiples of 2 and 3, I will write down common multiples. What will be the common multiples there? Well, common multiples we have underlined them: 6, 12, and 18. So we find that we are having common multiples as 6, 12, and 18. And now you can see that this is a multiplication table of 6. 6, 12, 18. What will be the next? 24, and so on. So these common multiples are also infinite. There are many common multiples. Even the number is multiple of itself. 2 is a multiple of 2, 3 is a multiple of 3. So the number is multiple of itself. Largest multiple we cannot say. Smallest multiple 2 and 3. I say that every number is a multiple of 1 because 1 multiplied by 1 is 1, 1 multiplied by 2 is 2, 1 multiplied by 3 is 3. So every number is a multiple of 1. So these are the some of the facts about the factors and multiples, that 1 is a factor of every number and every number is a multiple of 1. Well, every number is a factor of itself and every number is a multiple of itself. We are having limited number of factors for a number. We are having infinite number of multiples of a number. So these are a few differences in between factors and multiples. We are now talking about the common multiples. And if I said find out which is the smallest multiple of these number, or I will write down least common multiple of these numbers. Least common multiples of these numbers. Least common multiples of these numbers will be 6. Least common multiple of this number be 6. Now what is the use of this least common multiple? What to do with? Well, I am giving one example. If suppose there are two bells. The bell number 1, I will draw the figure and then explain about it. If there is one bell which ring every after 2 hours, and there is one more bell which is bell number 2, it rings every after 3 hours. So it rings every after 2 hours and the second bell rings every after 3 hours. If these two bells 1 and 2 ring simultaneously at 12 o'clock noon, at what time they will ring again simultaneously at the same time? At what time they are going to ring simultaneously? Same time. And what will be the next timing also? So next timing also we have to find out. Now you can see that the first bell it rings at 12. Okay, so I am writing the timing also. It ring at 12. Then it ring at 14. Okay, then it rings at 16. Then it rings at 18. Then it's 20, 22 and 24 we are having. Okay, then this bell number 2 we are writing the timing 12. After 3 hours means 12 plus 3 we are having 15. After 15 we are having 18, and after 18 we are having 21, and after 21 we are having 24. So this is the actually the timing in we can say 24-hour format I have written. You may be take the timing in 12-hour format, but it will be easy to understand in 24-hour format. So I have taken a 24-hour format. So first bell rings at 12 o'clock, 14 o'clock, 16, 18, 20, 22 and 24. Well, the second ring will ring at 12, 15, 18, 21 and 24. One thing is common in between them. See, bell ring at 12, then 14 and 16. Similarly, bell number 2 will ring at 12, 15 and 18. Now you can see that this time 18 and this time 18 means 18 o'clock, they both are going to ring simultaneously together. But we have drawn this picture, and on the picture we have written down all the timings. We have written down the time gap of the bells, for example 2 hours, 2 hours and 3 hours, and we have found it out, no doubt. But how to do this mathematically? Well, you can see it's 2 plus 2 plus 2, that will be of 6 hours, this time gap, and 3 plus 3, it is of 6 hours. It is of 6 hours again. And what we have find out, that the least common multiple for 2 and 3, we will find that is a 6. It is nothing but 6. So by just finding the least common multiple, LCM, we said that LCM of 2 and 3 when taken together is 6. So every after 6 hours the bells are going to ring at the same time, means simultaneously. They are going to ring simultaneously. So at 18 and 18 they are ring simultaneously again. Again, after a gap of 6 hours, you can see that 2 plus 2 plus 2 and 3 plus 3, that is 6. Even 2 plus 2 plus 2 is going to be the 6. So, at midnight, is at 12 hours or 00 hours, they again ring simultaneously. So, if the bells rings at 12 noon simultaneously, they will going to ring simultaneously at 6 evening, 6 p.m. and then at 12 night or 00 hours night. So this is a one example to list out, give the use of LCM in the mathematics. We will find out how to find out LCM and SCF using prime numbers and what is this mean by prime numbers in the next session.